7C.2 is on graphing cosine, but you've already learned how to graph the sine of x on the first worksheet. Ideally, you tried a few of the problems on the second worksheet and you were able to graph the cosine, which is slightly different than the sine graph. When I say slightly different, they are very similar to each other. Because they're both based off of the unit circle, they are going to look very similar to each other. The equations that we are using are so similar to each other. Y equals a sine of bx and y equals a cosine of bx. I have this a and the b in a different color because those a's and those b's do things to the graph, and I'm hoping after you did that first worksheet, you started seeing what happens when you do 2 sine of x or 1/2 sine of x. I'm hoping that you saw the amplitude changing. And if you weren't sure what amplitude meant, amplitude is the positive distance from its equilibrium. It is measured from the midline to the maximum or the midline to the minimum. Your worksheet uses equilibrium. I have been teaching with the word midline for the last 7 years, so I will use midline a lot more than equilibrium. It's the line in the middle. So when I'm thinking about amplitude, right next to this graph, I'm going to draw a real quick sine wave. There is my midline, also known as the line of the equilibrium line, apparently. Whoever wrote this worksheet calls it equilibrium. Amplitude is the distance from the midline to the top or from the midline to the bottom. It's that distance. It's the halfway distance. And when we started, the very first graph you had to graph was y equals 1 sine of x. That distance was a distance of 1. And that distance was a distance of 1. But it goes in the negative direction, Mr. Promo. How can you say that? Because distance is never negative. When you think about distance, there's no way that you could run 4 laps around a track, that's a mile, and then go, oh, my legs are tired, I'm going to go ahead and go backwards this time and go backwards 4 laps to erase the negative laps with the positive laps, and that way my legs will feel better. It doesn't work. Why doesn't it work? Because distance is always positive. And you can't have negative distance cancel out with positive distance. It doesn't make sense in real life. You've traveled for 2 miles if you go forwards 4 laps and backwards 4 laps. So with that being said, amplitude is always a positive distance. When you look at these examples that I have here, y equals negative 3 sine of x and y equals 1/2 cosine of x, the amplitude is 3, not negative 3. The a value is negative 3, but the amplitude can be found by doing the absolute value of a. And so literally, if you're looking for amplitude, whatever the a value is, it's the absolute value of that is what your amplitude is. And I say that because I remember seeing multiple choice questions that had negatives as a possibility, and you need to know amplitude is always a positive distance. With that being said, the way that I have taught, I've taught this, like I said, the last 7 years in AMA, and I love the fact that you are mostly freshmen in this class, some sophomores, but you will be better off than those AMA students learning it now. The way that I've been teaching sine and cosine is just using this mnemonic device. I use midline, extrema, midline, extrema, midline for sine, and I use extrema, midline, extrema, midline, extrema for cosine. It's a way for me to remember what happens during each quartile for the graph. If I look at these 2 graphs that are right here, I'm going to zoom in on them specifically. The red graph is the sine wave. The cosine is the blue graph. Those are the sine wave and the cosine wave. Now, each of these can be broken down into 4 quartiles. This quartile, the first quartile, second quartile. I'm trying not to touch the screen, but it's very hard. And the third quartile. And the fourth quartile. Even though there are 4 quartiles, quartile 4, even though there are 4 quartiles, we think of the beginning, that's still the beginning of the first quartile, okay? So there are going to be 5 different things. And if I look at the sine wave, I start at the midline, then I go to the extrema. Midline, extrema, midline, extrema, midline. It's the easiest way for me to remember what the sine graph is going to look like. So what I would like you to do is what I have my AMA students do. I have my AMA students put their left hand out in front of them just like this. So please put your left hand out in front of you with your elbow out. Put your right finger on your elbow. We're going to start on your elbow. And we're going to go and say the sine wave. Midline, extrema, midline, extrema's below, midline. Okay, so let's do that again. Far left, we're doing the sine wave. Ready? Midline, extrema, midline, extrema, midline. We're going to do it one more time, and I'm just going to point. And you are going to say it. Ready? Begin. Perfect. That is what we wrote down here as the mnemonic device. I don't confuse, I try not to confuse the positives and the negatives because that's a separate concept. If we do cosine, cosine doesn't start at the midline, cosine starts at the absolute extrema. And extrema means your maximum or your minimum. Okay? These are the extremes. They're either the max or the mins. So if I'm now doing cosine, I'm going to put my left elbow out just like I did before, except instead of starting here in the middle, I start above it for the cosine parent graph. And I say extrema, midline, extrema below, midline, extrema above. So please do that with me and say it out loud. Extrema, midline, extrema, midline, extrema. You're going to do it one more time, except this time I'm going to point at the screen. Ready? Begin.
Extrema, midline, extrema, midline, extrema.
Perfect. Those are the only 2 major differences. And the only thing that's going to change with that is this. Sometimes your A value is going to be positive. Sometimes your A value is going to be negative. If your A value is negative, if you have to graph -3 sine of x, and you're not going to be given a table anymore. The table thing was just to start you off, just so you could see where it comes from. You're going to be asked, hey, graph this, what's the graph look like? No tables. You're going to be using this extrema, midline, extrema for the quartiles, and it should all look the same. If A value is positive, this one's not. That would mean the first extrema, A is negative, the first extrema is negative. Instead of going up for sine, you would go down for sine and then go the other way. The negative reflects it over the x-axis, just like you learned in a previous unit. I'm hoping that makes sense to you. So, the last thing that we're going to do, the reason why I had to break the notes up the way that they are is because of worksheet 2, number 6. And so I did not have you write this down, and I'm not going to have you write this down. I just want you to see it. Worksheet number 2, number 6, it starts doing something different. everything was playing with the a value in these equations on 1 through 5. That's why I felt you should be able to do it. And then the b values, on number 6, they change one of the b values. That's going to do something completely different. The a values control the amplitude. The amplitude. How far up, how loud something is. Whoa! That's why they call the guitar things you plug the guitars into amps, because they amplify the sound waves. So you know. It's based off of this math stuff. They start playing with the b values here. That too is not multiplying the cosine. That too is multiplying the angle. So what's going to happen is something different's going to happen to this table, but they didn't include the table. They actually tell you in that worksheet, they say, hey, take every value, multiply it by 2, and then graph it. And I really felt like, hey, that doesn't even make sense. Where's the table? How they're supposed to do this? So I'm going to do it for you. I want you to watch. This is what should have been next to number 6. Instead, they just say graph it below. So I'm going to show you what the table should look like. It looks like this. If you have your angle is 0, and you have 2 times 0, that would be 0, and the cosine of 0 is 1. Okay? That's how it works. Pretty basic for that one. If I have 2 times pi over 6, 2 times pi over 6, 2 pi over 6, that is pi over 3. The cosine of pi over 3 is 1/2. So instead of us using pi over 6, we're actually, when we do 2 times pi over 6, we're going to be doing the cosine of pi over 3, which is 0.5. That's going to change some things. So I'm going to fill in this table, and let's see if we can follow along. I'm going to double this. It simplifies to pi over 2. Matter of fact, I'm just going to start doubling all these. If I double this, it's 2 pi over 3. If I double this, it is pi. If I double this, it is 4 pi over 3. If I double this, it is 3 pi over 2. If I double this, it is 5 pi over 3. If I double this, it is 2 pi. 2 pi. If I double that, it is 7 pi over 3. If I double that, it is 5 pi over 2. If I double that, it is 8 pi over 3. If I double that, it is 3 pi. If I double that, it is 10 pi over 3. If I double that, it's 7 pi over 2. If I double that, it's 11 pi over 3. If I double that, it is 4 pi. Okay, so I've doubled all the angles for you. And what you're supposed to figure out somehow is you're doing the cosine of this double angle. The cosine of pi over 2. I know what that is. It's 0. Remember, I know the unit circle very well, so I'm going to be using my hand trick to figure these things out. This is in quadrant 2. 2 pi over 3. The cosine is negative 1 over 2, negative 0.5. Cosine of pi, negative 1. 4 pi over 3, it's in quadrant 3. It's negative 0.5. 3 pi over 2, it is 0. 5 pi over 3 is 0.5. 2 pi, cosine is 1. So I got all those values done. I'm going to continue down here. I already have 1. I want you to trust me. If I were to plug in all these values, I would get the same thing as what it was above. With that entire table done now, and you look at it, what would the graph look like? The graph would look like this. Let me zoom in on this graph real quick, and actually I need to see these values. At 0, we would be at 1. I'm going to put 1 right there. I'm going to put -1 right there. At 0, we would be at 1. I'm sorry, let me erase that dot right there. I don't want that one there. Then we would be at 1/2 for pi over 6. For pi over 4, we'd be at 0. And what I want to do is I want to think, where am I going to be when I get back to where I started? I'm going to get back to where I started right here at pi radians. So I'm going to make my 4th quartile pi radians, which is a little bit different than what we've done before. I started out, look at, it's at 1. I get back to 1 at pi radians for my input, which means halfway is pi over 2, and half of that is pi over 4. And if that's 1 pi over 4, this is 2 pi over 4, this other one must be 3 pi over 4. I have my 4 quartiles. What I just taught you was, with cosine, you're supposed to have a mnemonic device that helps you graph on all 4 quartiles. It starts off at extrema, then at pi over 4 we would be at midline, and then at pi over 2 we would be at extrema, and at 3 pi over 4 we would be at midline, and then at pi we would be at extrema. It looks like this. It's a cosine graph, but what's different about this cosine graph that was different than what you did on all the previous problems was you have one period and it ends at pi radians. Matter of fact, if I were to continue down here and plug in values all the way to 2 pi radians, what you would notice is that you go extrema, midline, extrema, midline, extrema. You actually fit in one period, 2 periods of your cosine graph before it repeats itself. That's what a period is. Think about it like a class period. You have Mr. Promo for 1 hour and 58 minutes. And then you go, or you came from a class that you had for 1 hour and 58 minutes. And then you came from another class that was 1 hour and 58 minutes. They try to have your classes the same cycle, the same thing, the same amount of time, over and over and over again. That's what this is. It's a cycle that happens over and over again. It's called the period of the cosine graph. So with that being said, we're going to stop part 1 of the notes after that. And then I'm going to give you a chance to write down some of the notes that are below at this point.